Now you should be able to see my screen too. Alright, so I have got one confirmation. Thank you. So just give me 2 minutes. We'll get started. So I hope you remember this is where we stopped yesterday. We had some issue after we had an introduction about the partitions, and we have seen this issue. So today we will troubleshoot this issue. Okay, just give me 2 minutes. We'll get started. Hello everyone. So before starting the session, just wanted to check with you if you have any questions regarding the topics that we have covered so far.
Hey Bharat. Hey Bharat. Bharat, unmute. Sharon, hold on 1 second, Sharon. Mute. Bharat, what is the problem? Vinisha, can you hear me?
Yes, Ramesh, I can hear you.
Just silent, but okay.
Yes, Ramesh, I can hear you.
Okay, I think Bharat is calling me. You go ahead, Sharon. Just mute. Yeah, Sharon, are you ready?
Yeah,
Okay, yeah, let's go ahead.
okay. All right, everyone. So yesterday I've given you an uh, small introduction about partitions on a Linux system. So we have two different types of partitions, primary partitions and extended partitions. We can create a maximum of 4 primary partitions or stick to 3 and create an extended partition if you are looking for more than 4 partitions in the system. So inside an extended partition, which is considered as a container, we can create more number of logical partitions. So with respect to partitions, we have primarily 3 steps. The first one is we will be creating a raw partition from the hard disk. So hard disk in my system, uh, it is represented as /dev/sda. So the partitions are represented as /dev/sda1, sda2, sda3. Mostly SATA disks, if used as a hardware, you would see this notation of SDA. We have another category of hard disk called as IDE. With them you might find the representation of HDE. Okay, mostly these are the two categories. So the 3 steps which are involved are, from the hard disk you create a partition which is called as a raw partition. A raw partition is not ready to store the data. In order to store the data, we have to write the file system. So even in Windows, you create a drive and then you write the file system, NTFS or FAT file system, right? Similarly, here we write the file system called as ext4. Now, once the file system has been written, we need an access point to store the data inside the partition. So I have explained the access point concept yesterday, the mount point concept also. So once you create the access point, you start storing the data inside the partition. 3 steps. Now other than these 3 steps, say for example, uh, you have created a partition, you have created a mount point, okay, you have created a link between the two, and you have restarted the system. What happens? Just like uh, the concept that we have covered regarding the services. So you start a service, okay, you restart your system. The service will get stopped unless you start it again. If you want to make the service started automatically, what you do, you enable the service at the boot level. So you say for Red Hat 6, you say chkconfig service on. For Red Hat 7, what you do, systemctl enable service. So this step which is there, it will enable the service so that it gets started along with your system. Similarly, it is also applicable for the partitions. That means when you restart your system, generally the link between the partition and the access point is broken. In order to ensure that the link again gets created automatically post the restart process, what you have to do is you have to make an entry inside a file called as Cfs Tab. It is present under etc folder /etc/fs tab. If you open this folder, you would find the mount points and the corresponding access points. So far, what are the partitions we have? /dev sda1. The first partition is your boot partition, and the access point is /boot. The second partition is /, the entire file system,
Saran,
and the access point is, yeah.
are you sharing your screen? Because we stuck on one screen. Can you click on stop sharing and start sharing?
No. I'm just talking now because we are as a part of the troubleshooting exercise. I'm just repeating the topics that I've covered yesterday.
Okay, thank you, thank you. Sorry. Okay, thank
Yep. So the second partition is called /dev/sda2, and the access point is /. The third partition is swap partition. Swap partition is not mounted on the local file system because it is only used by the operating system. You remember swap, which is used along with RAM. So users do not directly access the swap space. That is the reason there is no access point for swap partition. And then the fourth partition that I showed you yesterday, /WSDA4, which is mounted under the access point called /mount6. So what I did yesterday is I just showed you an example on how to delete the partition. Okay, we have deleted the partition, and after deleting the partition, I told you that kernel maintains a partition. So these changes must be reflected in the kernel partition table. In order to reflect these changes, so the partition table needs to be updated. And in order to update that, either you run a part_probe command or part_x command, or you restart your system. So when you run part_probe command, you should get the command. So you just run part_probe. You should get the prompt back. So it will not display any message on the screen, but if you get the prompt back without any error message, that means you have successfully updated the kernel partition table. So while running a part_probe or part_x command, if it throws an error that it is still unable to update the kernel partition table, you have to restart your system. So I have restarted my system, and it is throwing an error stating that there is some problem. So while explaining all these steps, as I've said, in order to make a partition permanent, we make an entry inside fs tab file, right? That means inside the fs tab file, I have made an entry that for the fourth partition /dev sda4 /mount6 is the access point. I made an entry inside it just to ensure that whenever my system starts, automatically it creates the link between the partition and the access point. But while explaining the topic to you, what I did is I deleted the partition, but I have not deleted the entry which is there inside etc fs tab file. I had simply restarted the system. So what happens if you restart the system by deleting a partition without deleting an entry inside fs tab file? So as a part of the normal process, the system will start reading the fs tab file to check if there are any permanent links present. Permanent link means whether there are any links that have to be created between the partitions and the access points. So after checking, it has seen /dev sda1 access point is there, the partition is available, sda1 and sda2 are created, sda3 not needed, sda4 line is also there inside etc fs tab file, but that partition is physically not present in the system because we have deleted it. So there is a contradiction. The fs tab file says there is a permanent partition along with the access point. But what we did is we used fdisk utility and we deleted the partition. In the partition we have unmounted it and then we deleted the partition. But still there is an entry inside fs tab file. So when we have started the system, it is unable to identify that partition. Have you by any chance seen what is displayed on the screen? I know that it says some failed warning message and it came to a prompt where it is asking for root password for maintenance. Any these messages? See what is here. In Linux system, when you start your operating system or Linux operating system, it will display a bunch of messages on the screen. See, if possible, try to go through those messages. So it gives a lot of information to you. It will tell you how the system is starting. Okay, all the steps that we have previously seen, just go through the booting process again, initialization process again, and then see those error message, general comments that are displayed when the system starts. It is going to start each process. Similarly, when you shut down the system, one after the another, every process will be shut down. In case if a process didn't start successfully, it will display those messages on the screen. It will also provide you some hints. So here what it is saying, some file system, there is some problem. See, /dev sda1 is clean and has been successfully mounted. /dev sda2 is also mounted. So first of all, let's log into the maintenance mode or the single user mode. So I'm assuming that so etc fs tab is the problem. We will log in into that mode and then we will check further on what the issue is. Okay, so here so we have only 3 partitions. So here we have the 4th partition. Again, it says changing a read-only mode. So it is not allowing the root user to make the change. Excuse me. So quick question, did we cover how to reset the password? I mean, not after logging by going to the single user mode stage. Okay. So there are two ways of resetting the root password. That means one is for CentOS 6. It is slightly changed for CentOS 7. So for CentOS 6 it is very simple. So I will show that steps to you today. For CentOS 7 we will cover that later. Alright, so what I did is I have simply created /dev SDA4, the fourth partition which the system is expecting. That has fixed the issue. For now, just uh, focus on creating the partitions concept once again. So Cfs Tab. So this is the file that contains partition and the corresponding mounting points. So I have removed it. So this file is a very important file. Here you can see the mount points and also the partition. Now instead of a partition there is something called UUID. It's like a unique identification number that is allocated for the partition. So there is this command called blkid. If you run it, it will give the unique identification number corresponding to each of the partitions that we have created in the system. So inside Cfs Tab file, there are three ways. One is you can mention /dev sda123, that notation, or you can mention this UID. The moment you create a partition, this gets generated in the system. Or you can set an alias name to these partitions. Okay, I'll tell you how to create alias name. But usually during the practice, we simply go with the standard notation of making these entries. Okay, so what is the partition? What is the access point? It can be any point in the system. So mount 6. What is the file system? ext4. And what are the permissions that are associated with the partition? And then we have 00. I'll explain what they are. Okay, so what this FSTab file will do, it will ensure that it will create that link between the partition and the corresponding access point, so that the partition is readily available for you after the system gets started. Otherwise, if you don't make an entry, the link is not created. So you have to manually do mount /dev/sda4 mount 6, something like this. So it says that the device is already mounted. So how to check it? Mount grep there, you see SDA4 is there. We have a question. Can we also see mounting information in /dev mapper? As far as I know, I have never tried looking into that file. Okay, got it. /dev mapper. You might have seen some partitions created under /dev mapper. So that's the reason you might have asked this question. Is that right? So usually in organizations, they create a different kind of partition. So if we create an LVM partition, okay, so when we reach LVM topic, that LVM partition has a completely different notation. As far as I remember, it creates those partitions somewhere in /dev mapper. So instead of SDA, because LVM concept is altogether different. Okay, please ask me the same. Just remind me the same question when we reach LVM concept. Then we will go through the path. So in fact, instead of /dev SDA, we will have a similar path, dev mapper, some LVM name, whatever that we create. So then we will go through it again. So for now, so this is the partition. You are clear with Cfs Tab, right? So we remove the entry in the FS Tab. So and then we are going to unmount it. So yesterday we unmounted it, but we have not removed the entry in the FS Tab. So I'm unmounting it. Either you say unmount /dev SDA4, or you can also say unmount /mount 6. Both the steps will work. Okay, and when you are unmounting it, in case you are under this folder, okay, because we are mounting the partition to the same folder, you might see an error message stating that the device or the resource is currently busy. Make sure that you are not in the folder, or let us quickly cross check. Okay, that is the error message you will see. So back to the utility. fdisk /dev SDA. So P, okay, sorry, M is to get the help. So among all this list, P is to print the partition table, and here you can see the partition. Same to fdisk-l command. Press M again. D is to delete a partition. List known partition types. So here in this output you can see here, right, /dev sda2 Linux based partition. This is a swap partition. So these are the types that are present in L. There are a lot of options available, and here above 83 there is something. 83 is Linux, 82 is the swap partition. Okay, and what else we have? Q is to quit without saving the changes. W is write table to the disk and exit. It is only going to write it to the disk, not the kernel partition table. Okay, and T is to toggle change a partition system's ID. By default, when we create a partition, it will assign uh, Linux as the system type. But if we want to change it, so we will use that option when we create swap partition. So we create a partition first. It will have this label as Linux. Then we press T toggle and then change the partition ID from Linux to swap or Solaris. Okay, these are pretty much the options that we'll use. Again, so we have 4 partitions. Press D to delete 4th partition. Okay, now print. So this is temporarily displaying you about the changes that will be reflected when you save it. W is to save and quit. And I said after pressing W you need to do part probe. You can see the message on the screen, part probe or part X. Again, I did not successfully execute part probe, so I'm quickly restarting. So another important point, so based on the partitions concept, we will again go through the LVM concept also. So please make sure you have understood the concept, otherwise ask me questions. Okay. So what I was saying is, so I have created, uh, so that changes are reflecting post the restart, right? So now I have started it once again. So here we have, I have chosen the option N to create a new partition. So here we have two types, primary, extended. So what we'll do is, we'll quickly start with the primary partition. Let us not save the changes. We will restart and I'll show you how to create extended partition. Both the steps are similar. So we already have three primary. So we can create another primary partition, the fourth one, or make it an extended, so that inside the extended partition we can create logical partitions. Okay, so I've chosen P, and here it is asking me to provide information about cylinders. So cylinders means when writing file system, I'll show you those messages. You can see those messages on the screen, which uh, so writing a file system is similar to drawing boundary walls on, kind of, just assume it, on your raw partition. So boundary walls and some, some additional information. So we can see that when we write the file system. So basically the hard disk space which is there, okay, say it is 10 GB of space that you have allocated. So this 10 GB is further split in terms of blocks. System also has a calculation in terms of cylinders. Okay, so let us not go deep into what the blocks are, what would be the size of the cylinder. Rather, just assume that it calculates the size of the space that you are allocating in terms of cylinders. But we need not have to know the information about cylinders, but what we can say is, so it says the range that cylinder 2721 to 3263, this is the free space available. Okay, what we say is, press enter to start with the first point, so it will take the default value. Now for the second point, as it says, you can mention size in terms of KB, MB or GB, plus 100 M. So that way, in a user understandable format, we can give the size. Okay, so now that I've given the size, P to print, 4 primary partitions are created in the system. Let us, just for the sake of testing, try creating another partition. Press N to create new. So it says you must delete some partition and add an extended partition first. So it will not allow you to create any partitions in the system. Okay, clear, right? So Q to quit without saving the changes. Again start. P, 3 partitions we have. N, create a new partition. Now choose E, extended. Okay, now inside extended we have to create logical partitions. So what we'll do is, leave the entire space, with the entire space that we have, we'll create a container. Enter, enter. So it will take both the default values. Press P, this is your extended. We cannot format an extended partition. It is just like creating a container. Okay, now you can again say N to create new partition. See, inside the container, now it starts creating logical partitions. Again start, enter, plus 100 created. We have extended, and inside extended we have created the first logical partition. Press N again. It is again asking you to provide. So it is allowing you to create logical partition. Press enter. Plus 100 MB. Press P. Okay, so it is allowing you to create like this. As long as you have empty space, you can create those partitions. Okay, and here you can see the information in case if you're interested. So as a part of /WSDA, this is the total size allocated for the disk. And if you do a deep dive, about hard disk, what, how it is partitioned, what are the other building blocks, that you can get information about these heads, sectors, cylinders. Usually they are all right, everyone. Yes, there is a small transient issue with the network, so the audio is lost. I can see a pop-up on my screen, so I did not continue. I was just waiting for the network to re-establish. So I hope you all can hear me now, because I can see the message on my screen. So we have created primary and secondary. So these changes we have to update in the kernel table, kernel partition table, and then we will write the file system. Writing the file system, creating mount point, steps are same for both primary and extended. The only difference is the creation part. So that you have seen already. Okay, now the changes are reflecting. MKFS is the command. You can remember it like make file system. Okay, you can say MKFS, press tab twice. You can see the options available. There are different types of file systems that the Linux operating system supports. So ext4 is the latest among 2, 3, and 4. So you can say dot ext4 space. Since SDF4 is extended, it's just a container. We don't write a file system on that or try doing it. what does it say? So it is not writing the file system. It says that it is too big for a file system with 0 block. So it is just a container, okay, that doesn't occupy space also. It's just like a boundary wall. So writing file system concept is the extended container. Okay, so 5. So here you can see when writing the file system, it is displaying the block size. Remember I said uh, data is basically transferred, okay, in terms of blocks. So that is why like /tab sda 1 2 3, these are called as block device files. You remember we have gone through different types of files. /tab we have block 1 2 3, these are called as a block special file because data is transferred in terms of blocks. Okay, similarly the terminal files, they are called as uh, character device files, character special file. So because you give data is transferred in terms of characters. Okay, so like that. So you can see there is a lot of information here. Every file in a Linux operating system have a unique identification number called as an inode number. See, for this file there is a unique identification number. If you take all the files, every file has a unique identification number. Okay, so I'm going to rephrase the same line again. So this unique identification number which I said is similar to a data structure. Okay, that means uh, an inode number is like a data structure. So it is not just this number, but an inode number maintains metadata about a file. So metadata in general means data about data. That means, so when you create a file, that file has permissions associated, that file has owner, group information, as per the amount of space available. So that is additional information. Okay, then you provide, when you create a file, how do you create it? So you say touch space file name. So file name is also an attribute of a file. In fact, file means not the file name, it is the underlying inode number. So when you write a file system, okay, so it is going to create inode numbers, data structures on your file system. So we'll go through this again. So we create 6. I'm writing it again. So on this partition, it has allocated 28,112 inodes for the 100 MB space we have allocated. That means we can create this many files on this partition. Okay, so this many files or directories. Even directory also has an identification number, inode number. So when you are creating a file, actually you are linking an existing inode number, the data structure, to a file name. So immediately the information about that file will be stored inside the inode number, all the metadata. Similarly, when you delete a file, what you're doing is you're simply breaking that link between the inode number and the file. Actually the file is not deleted, in fact just the link is broken, so you are unable to access the data present in the file. So the data will be there inside the inode number, or the data structure called as inode. Okay, so it's similar to the partition concept. So it is not, once you break the link, it is not possible to create it again. And when you create a new file, that same inode number might be reallocated, and whatever, since you are doing it for the first time, all the content will be erased and it will be given as a new inode number. So all this kind of information will be written as a part of writing the file system. So that is what it is. So once you have written the file system, now you can link it to any of the access point. So mkdir slash, I'm just reading randomly, 5 exists, 6 is already there. So mount sdf5 at 5, mount sds6. So the links have been created. Now you can go to the access point and create something. I've created 3 directories. Similarly, go to 6. Okay. Yeah. So there is a point here. Question: if I create many number of files such that it reaches the inode limit, will it throw an error when I create a new file? Say the limit is 100 inodes, and after creating 100 you try to create another one, okay, then it might throw an error for you. Well, I haven't done a deep dive into the relationship between the inode and the corresponding space. That means, so my understanding is, if there is a 100 MB of space, okay, so this space, uh, I cannot say it that way. Okay, so here this partition is 100 MB, okay, and there are 28,000 inode numbers allocated. So even if we split it, each inode, how much it is going to take? Hardly 4 KB in size, right? Uh, Approximately. But if you create a new file, okay, let's check it. But the answer for your question is yes, it will throw an error. It will not allow you to create a new file, because we can test the same scenario, because we have a concept called quotas. Okay, in quotas, what we do is we allocate some fixed amount of space to a user. So we restrict the user, saying that you have to make use of this 100 MB of space only. So there we can either uh, allocate space in terms of the size, or we can also allocate space in terms of inode numbers. So we tell him that you can create a maximum of 10 inode numbers, 10 inodes. Okay, so there we will also test it. So we create 10, and when we create the 11th one, it will throw an error stating that you are not allowed to create another inode. So that is the limit that we set. Similarly, the operating system sets a limit for us based on the amount of space that we have allocated. So we cannot cross that limit. Well, if you want, you can also cross check it. Maybe write a small loop that will create the 28,000 files that we have, and then try creating additional one to check whether it allows you or not. So my answer is no, it will not allow. So you can cross check it. I even mentioned the process how to cross check, but I would suggest that wait till quotas concept where we perform a similar operation. So here we have seen, we have accessed. So unmount I have unmounted mount 5. Six. So if you go to the same place again, the data won't be available because the data is stored inside the partition. Okay, and mount 5 and 6 are only access points. So that's why we cross check it. Clear? So Ramesh, so was I able to answer your question regarding the inodes, or do you still have anything? Okay, I didn't check your message. Okay. So this is how we create partitions in the system. Okay. So I would suggest this concept of creating partitions. Okay. And then we will move on to the LVM concept. Now you have seen how to create primary, secondary partition. Let us quickly uh, create a swap partition also. Okay. So for swap, there is a little change in the steps. Initially, it would be the same. So again, fdisk /dev sda. So the swap, anyhow, I mean practically it is a space that is available on your hard disk only. So we allocate the space on the hard disk for swap, but it is used to assist RAM. Okay. So I created fdisk /dev sda and print, go for new, and whatever is left, let us give it okay. And then here we have to use toggle, or let us print first. So SDA7 should be swap, then press T for 7th, and I'm going to directly give it 82 is swap. Okay, W, save. Let me quickly restart. So the process remains the same. Only one step you have where you have to toggle the type to swap. Okay. So that is using fdisk. Then the next step what we do is we write the file system, right? For swap, uh, it is not mkfs. Okay. So mkfs is only for normal partition. So that is where the differentiation comes. You need to use a command called mkswap. Okay, mkswap. Then that will create the swap related file system for you. So now with that step, the swap partition is ready, but the system will not take it like that. So you have to enable the swap partition, then only the system will take it. Okay, so we'll see how to enable the swap partition next. There is a command called swap on, swapon. So swap on will enable the swap partition in the system. Make swap /dev sda7. So we have two commands, swap on, swap off. Okay, and -s, swap on -s. sorry, it is -a, I think. Mhm. So I'm just trying to check the argument using which. So we know that there is a partition that is already been allocated for swap, right? /dev sda3. Okay, /swap1 /dev sda7. So you can see that we have enabled the swap partition in the system. So this is again, we have temporarily enabled it. If you want to make it permanent, we have to update the same inside etc Cfs Tab file. So there is already one entry over there. Okay. So this entry is missing. That's the reason. So when I do swap on -s, previously there was no output because the existing swap partition which is there, it is not permanently mounted. That means mounting is the wrong word. So it is not present in Fs tab. So what happens if it is not there in Fs tab? When I restart the system, that swap on process will not happen. If it is there inside Fs tab, it is automatically enabled, okay, by running the swap on command. Since it is not there, swap on didn't happen on the swap partition. So that is why it is not displaying that. Say for example, now we have this partition, right? We can, if I want to enable the other one, I can disable this and enable SDA3. So swap on -s will display that. So usually after post the installation process, you will see this entry inside Fs tab. So under these two partitions, there will be another partition. Let's create it. What is it? Dev SDA3. There is no access points. You will name it as swap. Okay. And defaults 0 0. Save and quit. So from now on, automatically, even after a restart, swap will be enabled. Okay, so it is not mandatory because we have plenty of RAM available. So swap is only necessary when you have such kind of applications which use a lot of RAM, and RAM might want to move the pages to the swap. Okay, so I show it as a part of creation, but while creating the partitions, I would have removed it from the Fs tab file. So this is how you create primary partitions, you create extended partition, and you create swap partitions. Any questions so far? Alright, so let us check password reset process now. This is only for CentOS 6, okay? 7 it is different, so I will show that later. So first of all, restart, go to the grub prompt. Okay, you need to wait there. Now here, usually there will be only one line. Okay, did I mention that uh, you can install multiple kernels in your system, in Linux system? So in Linux system, if you remember the architecture, there is only one kernel present in the architecture, right? But it is possible to install multiple kernels. So what I mean is, so now we are using CentOS 6 operating system. Okay, so operating system is using one version of kernel. The operating system version is different, kernel version is different. Okay, kernel is developed and maintained separately. There is a website called kernel.org. There you can go and check. So before a new version of the operating system comes, that means you heard about Red Hat 5, Red Hat 6, Red Hat 7. Okay, so before one version moves to the another, there can be multiple versions of kernels that are released. Okay, so here whatever that you are seeing, 2.6.32-504, 2.6.32-573. So it's like some major changes, minor changes of versions will be present. Okay, so the reason why I'm talking about this is in organizations again, say there is one version of kernel that is being used as a part of the operating system. Okay, and this kernel is not compatible with some of the applications, or people have identified some bug, or there might be some new version released with better performance. Okay, some kind of fine tuning has been done. Things that keep happening, or a new feature has been added and that has been released, and your organization felt that making use of the latest version of kernel would help. So you cannot simply just install the latest version, and I mean you can't just install it in production, right? Before installing it in production, you need to check the compatibility of that kernel with the existing applications. So that is how every software will be released. So first of all, we check the compatibility with the existing ones. So in a Linux system, we can parallelly install multiple kernels. At the time of starting the operating system, we can choose the kernel. Okay, so if you just choose the kernel, rest of the architecture, all the components which are there, they'll remain the same. Only the kernel is something that you are changing. So you can imagine it like you have 5 different blocks of the operating system. When you are starting, what you do is you combine the blocks and start the system. Okay, one of the block is kernel. So when you have installed a new kernel, you have 6 blocks present, like 2 blocks of kernel, but only one will be active, the other is inactive. So when you are restarting, what you do is you choose the block that has to be active. Okay, so then rest of the components will try to start the system by interacting with that kernel only. So when you are starting it that way, you can get to know, then you can start, you can check whether it has successfully started or not, whether there are any error messages. Okay, and then you can start running your applications and see whether they are running fine. Okay, and go through the kernel error messages and see if there are any issues. Okay, so like that we can check the new kernel version, you can test it. Okay, so here in my system I have 3 different versions of kernel. So if you want, you can simply upgrade by using yum command itself. So yum upgrade kernel would automatically pull the latest version and install it in the system. Or if you want, you can install a specific version also. Okay, so this is pretty much about the kernel. So we have question here, do we have same kernel for CentOS and Red Hat Enterprise Linux? The kernel used is the same for both. So it is the same in the sense the source of kernel is the same. Okay, so it again depends. So if I'm using a CentOS 6 system and Red Hat 6, okay, there can be change in the major and minor versions of the kernel. Okay, if you want, you can also upgrade it to that version of the kernel, but the source is the same, the kernel.org. That is from where you get the kernel. Both CentOS and Red Hat will be making use of the same set of packages, same set of libraries, other than any uh, Red Hat specific features which are commercial in nature. Everything is the same. You don't see the name Red Hat, you see it as CentOS. Okay, so next question is how kernel and operating system are related. Well, kernel is the core component of the operating system. Okay, so a kernel, if you integrate it to other features, there is something called GNU software. Okay, so along with the kernel, we have a lot of other libraries, utilities, okay, and all the graphical components which are there, shells which are there. So basically, these are all integrated to the kernel. Other than the kernel, even kernel is under GNU license. It is like you write something, okay, and you make it part of GNU so that it is open sourced. Everyone can use it. Everyone can change it, but the condition is whatever enhancements that you do it and again make it under the GNU license so that it is available for free. So kernel along with the other utilities. So again back to the architecture diagram. Other than the kernel, we have other utilities, shells, okay, and other layers present. Combining them all together, we call it as operating system. But kernel handles most of the kernel is responsible for most of the things that happen in the operating system. All the internals are taken care by the kernel only. Does that answer your question? Okay. Now the first one here. So let me quickly show you the components here. If you press E, there are instructions at the bottom. Go through the instructions, okay? So press E to edit this line. When you edit it, you can see that HD0, 0, this is like the first partition, okay? And also the first operating system. If you have multiple operating systems, then this number would change. The second line is the kernel version, and the third one is init.rd. So initial RAM file system, initial RAM disk. RD means RAM disk, RAMFS means RAM file system. So this, if you remember the booting process that we had seen in the first class, it will help you in. So initial RAM file system is a temporary file system. So when I say file system, imagine the file system structure that we have in Linux. The inverse root structure / other directories and all, right? So there we can create partitions, we can perform operations, we can do a lot of things, right? Similarly, imagine that the RAM file system is a baby of the actual file system. So we make use of this init RAMFS. It is a temporary file system. So this is used in order to create the actual file system. Using this temporary file system, we create the actual file system as a part of the booting process. So that is why it is used. The other one is kernel. So to this kernel, again there are instructions at the bottom. Press E to edit. So there are a lot of arguments that are associated. This forms the entire line. If you press escape, you go back. Press escape again, you go back. Edit, edit. So one of the argument that is passed to the kernel is the run level 1, means single run level 1, like run level 3 and 5, run level 1. If you can also mention as S, means single user mode. It is going to be only the root user. Okay, press 1 or yes. Now once you press 1, press enter. Observe the difference. E to edit. If I press, say I removed it, 1 second, enter. So we are back to the normal state. Press E. You can see at the end there is nothing. Space 1. Now I'm pressing escape. If you press escape, press E, the 1 will be lost. So press 1 and enter. Then 1 will be stored. Enter. Okay. Now press escape and start your system. Oh, I'm sorry. So there I think you have to press B to boot using that kernel argument. So here it says B to boot. Edit, press 1, enter. Now press B to boot. So if you press escape, it will go through the normal process. So please, rather than following the instructions, just read the instructions at the bottom. Okay, so there won't be confusion on how to edit and how to boot using the new run level. So run level 1 is also called as a single user mode. So in single user mode, the system will not ask you to provide credentials. It will directly land up in a shell as a root user. So now you might have, you should have a question in your mind that where is the security with Linux system? So any Linux system, I can open the grub page, I can enter into the single user mode. Now I have landed up in a shell. Now if I do password, I successfully changed the password also. So where does the security lies? Well, by default, access to the grub is allowed, but usually it is possible to block the access to this grub access. You can see the grub page, you can only choose the operating system to start with, but in order to edit the argument to the kernel, we can block the user. You can set up a password and block the user, so that only by providing the password he can log in into the kernel page and provide arguments to come to the single user mode. So this is the single user mode. So usually if you have some problem, if you forgot the password, you can come here. The same topic, the same concept is a little different with Red Hat 7. So we have grub in Red Hat CentOS 6 or Red Hat 6, whereas we have grub 2, the latest grub in Red Hat 7. That is why we have there is a change in the single user mode also. So that we'll see later. Okay, so just practice the partition topic and also the uh, password reset topic, and so we'll wind up the session here today. Okay, we'll try to. I'm not sure whether you're getting enough time to practice. So feel free to mention if it is not sufficient. Okay, so try to practice these things, and we'll start with a new topic tomorrow. Well, that's all I wanted to cover in today's class. Other than that, if you have any questions, I'm happy to answer now. All right, everyone. If you don't have any other questions for the day, so we can wind up the session now. See you in tomorrow class. Have a good day. Bye.